Welcome, folks. This is our final session in this year's 2023 GSE virtual conference, certainly for the CICS working group. There are other sessions and other streams that will be going on after this. Stuart Francis has very kindly stepped in at the last minute for Will Yates, who's very poorly, did the last presentation from his sickbed. After I've read the title out, hopefully there'll be some time left for the presentation, but it's Cloud Native CICS Application Development and Deployment with the IBM Z and Cloud Modernization Stack. I should be saying Z, really. I'm British, for goodness sake. So, Stu, I know you'll pick up on any questions that we call out to you, and you'll be able to deal with those. But if you can, I've said already, put those in the chat because you're all on mute. So without further ado, Stuart, could you take it away, please?
Thank you very much, Rob. Yes, so I'm filling in for Will today. So this is a presentation that we put together for introducing the idea of doing cloud native CICS application development and deployment with the IBM Z and Cloud Modernization Stack. Now, as Rob points out, that is quite a wordy title, and there's quite a bit to unpack in there. So I'm going to spend a bit of time at the start of this presentation talking about some of the business drivers behind needing to modernize applications on ZOS and what benefits business can hope to get out of that, to kind of explain a bit of the trends in the industry for why it's important. Then talk a little bit about hybrid cloud and how that relates to what we're doing on ZOS. And we'll spend the bulk of the presentation talking about how our new offering in that space, the IBM Z and Cloud Modernization Stack, can help you take advantage of hybrid cloud architectures and cloud native development patterns to help you deliver modernization for ZOS and help claim some development agility and faster time to market as well. We'll be doing that by going through a collection of use cases for kind of things you can do that the IBM Z Cloud and Mod Stack makes more realizable for you. And then hopefully I have a video showing some of the Cloud and Mod Stack tech in action. So if I can get the video sharing working, then maybe we'll try and step through that video as well. We'll go through that and I can show you some of the actual technology as kind of in situ working in a kind of real case study. So I do have copious speaker notes here for this deck, so apologies if I'm looking down here a lot, because I'm probably reading them to remind me what's going on. So, first let's have a chat about the business imperatives driving the need to modernize on ZOS. The kind of facts you'll see on this chart are from a collection of articles and industry surveys. Most of the data you'll see is from this McKinsey 2021 global report on the state of new business building. McKinsey are a management consultancy firm, and that article is quite an interesting read about how important businesses see net new business generation being over the next 4 years. There's like about 1,000 survey respondents in there who are business leaders, and they do an interesting job of comparing results to a similar survey that they conducted 3 years previously. And one of the interesting outcomes of that is there is one of the questions is talking about how important businesses see new business generation being in the next 4 years, when this was conducted, I guess it's 5 years when this was conducted in 2021. And they'd asked this question previously, and there was a much more marked increase in priority of new business in the 2021 survey. In fact, 20%, I think it was 20% of respondents had said that it's in their top 3 priorities for the next, for the next 5 years, which was quite a big uptick from where it had been 3 years previously. It is important to unpack what they mean by new business in this. It's not complete greenfield development, but it's looking at the idea of taking existing investment you have, existing infrastructure, exactly the sort of thing we will have on ZOS, and being able to create new revenue streams and new opportunities out of that by using the assets that you have there in some way that you haven't intended before. There's some interesting discussion in there about practice as well, about kind of the relative success rate of allowing those teams developing new business to be independent and develop their own methodologies behind doing things, but still kind of centralized strategy around there. But it is quite an interesting read looking through that one. One of the kind of the headline statement on the left-hand side here from that survey talks about how they say that by 2026, half of their revenue will come from businesses, products and services that do not exist today. Actually, if you read the article, what they say is the inverse of that. It's that they expect 50% of their revenue to come from businesses that do exist today. So by extension, the other 50% is from businesses that do not exist today. I guess it very much depends who you're asking and what their business is as to the relevance of that, but it does show a kind of broad trend that in order to remain successful, businesses are going to have some way of developing these new revenue streams to stand alongside the existing ones they have at the moment. There are a few other articles that are referenced on this slide talking about other opportunities as well. So one of the more significant ones is to do with reducing the cost of adhering to compliance regulations. So that's the bottom point in the blue box there, talking about it's kind of a combination of the cost of implementing compliance regulations and the penalties that are applied for not adhering to compliance regulations being a kind of silent tax on business. So being able to minimize the cost of implementing compliance regulations can really help with the business's bottom line. And the other interesting article that's linked from here is talking about opportunity cost, which is about experiences that businesses have retaining customers who experience poor poor digital experience. It's I think the 537 billion is maybe like a little hard to pin down scientifically. I think their methodology is something like, this is how big the market is, this is how many people leave services and move to a different service provider, and what percentage of them say that that was due to bad customer experience, and that the company, by addressing that, could have kept them. But undoubtedly, there's a big opportunity there if you're able to deliver customer experiences that really matter to improve customer retention. And that's going to be a modernization objective as well. How do you make the best use of your data to give people access to the experiences they need? So one of the kind of inevitabilities around modernization is going to be the need for hybrid cloud. So every time I kind of go through things like hybrid cloud, multi-cloud, private cloud, public cloud, kind of helps me to kind of go back and try and relate all of those things to each other. So hybrid cloud is the reason I kind of say that it's an inevitability, is because I don't think that for large businesses it's realistic that people will be able to converge onto a single cloud provider for all of their infrastructure and migrate all of their existing assets from where they are today, be that on multiple different cloud providers, and have some kind of single cloud provider you pick as your strategic option and converge around that one. And actually, I think there are some pretty significant drawbacks to that approach as a strategy as well, because you're going to tie yourself to a single provider and you're going to lose the opportunity to run your workload in the place that's the best fit for it. So, you might be able to retain some agility by being able to move some workload between different cloud providers, or run some workload on your existing private infrastructure like ZOS, or on a private cloud platform, or increasingly what we're seeing in the industry is being able to run workload nearer to the consumers on edge networks as well. So it's going to be increasingly the case that business is going to be more distributed around the places that are most appropriate for that to work. And that's going to give, or workload's going to be distributed, and that's going to give businesses a real problem in working out how to manage all of this when you're talking about similar kind of business, maybe shared access to data, how you configure communications between them, how you scale all of these services independently to handle differences in load, where that might be scaling some services on one public cloud provider in concert with another private cloud provider, in concert with some traditional infrastructure, in concert with some edge devices. And hybrid cloud is the answer to that problem of having your workload run in the place which makes most sense for that workload to run, but having one single integrated fabric to be able to tie everything together and orchestrate your workload across all of these providers. And that is not just a business benefit in terms of operations, but also in terms of giving developers a common experience for delivering workload, not having to change their practices depending on where that workload is intended to run, and be able to have the flexibility to move that workload to a more appropriate place as maybe that changes in the future as well. So our IBM and Red Hat's answer to private cloud is Red Hat's OpenShift platform, which can orchestrate across public cloud providers, existing infrastructure, your existing internal private clouds and edge networks as well. And in addition to the base OpenShift offering, we have a number of offerings that sit on top of that that bring real quality of development and implementation of common patterns with a kind of different portfolios of products that help target different use cases, which we refer to as cloud packs. And obviously we have our consulting teams which can help with implementation of all that sort of stuff as well. I'm going to be talking to you today about the IBM Z and Cloud Modernization stack, which is very similar to what we've referred to elsewhere as cloud packs, in terms of it being a suite of different pieces of software. You can have access to all of the software in this suite to implement a variety of different cloud native business goals. And the model for charging for that is you pay for which parts of that you use. So you decide based on use case, but have access to all of the technology. So kind of the cloud packs are shown in this diagram there, and sitting alongside them for cloud is our IBM Z and Cloud Modernization stack. So interesting piece about the IBM Z and Cloud Mod stack is that all of the software in the mod stack is designed to be cloud native. So a lot of the experiences we're talking about delivering here, they're the sort of things where you don't actually have to, for developers, they don't actually have to install any desktop software. All of the to do with things like dynamically provisioning infrastructure that they need when they need it for the task they're trying to do, and providing pre-integrated software in that kind of cloud self-provisioned experience to help them be able to deliver on a set of different use cases we have identified as being important for business modernization goals. And the idea behind this is to help make it faster to carry out some of these objectives by giving kind of nice patterns for people to follow and kind of pre-integrated tool set to make that easier to achieve. And all of this software runs natively on Red Hat OpenShift, and we'll see that kind of in a demo video at the end of an example of some of this running in action. And then the nice thing about it being OpenShift native is that you're looking at skills that are going to be more common in the industry for people who aren't necessarily familiar with the Z platform. So you're talking about people who already are used to the technology in OpenShift and other ways of developing for the OpenShift platform, but also the patterns of cloud native development, the methodology of putting source code into SCMs like Git, creating pull requests, have automated DevOps pipelines, automatically build and deploy that software to provisioned infrastructure to be able to carry out tests, things like that. We're also talking about things like access to programming languages that aren't the ones that we've traditionally used on ZOS, but looking at patterns for how to use languages like Python, Node.js, and Go to extend your existing ZOS applications, deliver existing functionality on top of those. And there's actually one of the references that we have in this deck is a nice example of that kind of usage pattern. So there's a few facets to the IBM Z and cloud modernization stack. In reality, it's a collection of a few different offerings around that are all OpenShift native, but the use cases that we'll present will hopefully demonstrate that the value you get out of the mod stack is that you can use all of these technologies in concert to help achieve one of these goals, and that the real value is in the kind of collective of all of these products. So a lot of what we're talking about, I'll try and kind of say this bit's the sort of thing that would be provided by product A, or this bit's the sort of thing that would be provided by product B, but they're all kind of included in the package of the mod stack and pre-integrated. So some of the sort of capabilities we have in mod stack are simple access to applications and data through technologies like ZOS Connect. You might have heard ZOS Connect previously in its support for running natively on ZOS and tooling based on their Eclipse plugin. There's been a whole bunch of work has gone into the ZOS Connect to enable it to support OpenAPI 3 and to support real cloud native developer patterns as well. And hopefully if we get the video working, I can take you through a demo that shows some of that off. I think it's really slick experience for API enabling ZOS programs. And the experience of creating them is really easy, but the experience of distributing the tooling, the fact that it feels cloud native, it all kind of ties together really nicely. And then there's a lot of other pieces to the mod stack as well. The part on the right here talking about standardized IT automation is talking about some products that are included in mod stack called ZOS Cloud Broker and Z Package Manager, and that's introducing a new way of thinking about installing software and utility libraries onto ZOS, so to minimize the need for specialist ZOS skills when installing software, maintaining that software and those libraries. A lot of this will be around installing things like the what we refer to as open enterprise languages. So that's support for Python, Go, and Node. A lot of this will be talking about how to manage those language environments, how to keep those up to date, how to install them without requiring traditional ZOS skills to manage that installation. And then there's some really sophisticated capabilities supporting cloud native development in a product group called WASI, which is WAZI, which you may have heard of. The WASI project is all about delivering cloud native developer experiences. So standing up provisioned developer environments on OpenShift native, and by developer environments, I mean the tools that developers will use, sit down and type into when writing code. So we're talking about provisioning cloud-based IDEs on your cloud platform on OpenShift, but we're also talking about provisioning virtualized ZOS environments for deploying applications into. So all of the needs of a developer in terms of software and infrastructure in order to perform a development change can be dynamically provisioned for them. They'll have access to all the tools that they need, all pre-integrated. So part of the WASI portfolio is some analytical tools called WASI Analyze. There's the cloud IDE support, which is called WASI Code. And then there's the virtualized ZOS on your private cloud on OpenShift, which is called WASI Sandbox. And all of these kind of products, WASI Portfolio, Package Manager, Cloud Broker, and then there's some other pieces which we'll cover later, are all part of ModStack. And you essentially put together solutions with tools from ModStack, and you only pay for the capabilities from ModStack that you use, and it all runs natively on OpenShift. Yeah, so I think I actually covered most of this when I was talking about the previous slide, but yeah, you have the application analysis from the WASI portfolio, creating and deploying APIs from ZOS Connect, cloud native development from the WASI portfolio, so WASI Sandbox and WASI Code, standardized automation from Cloud Broker and Z Package Manager. So this slide is kind of self-explanatory, but it's just a few customer references that we've collected, talking about the kind of approach to ModStack. So I'm not going to go through those now, but they're in the deck if you'd like to hear kind of other people's opinion on which way we're going. But hopefully, we hope that our thinking is relatively aligned with yours in terms of bringing cloud native developer experiences to ZOS and making it as easy as possible for you to kind of take advantage of that to modernize your applications. So there is a selection of use cases which we were bearing in mind as we worked on ModStack, the kind of things we want to improve, make really easy to develop in a cloud native way. We're going to be going through some of those now. All of these use cases are backed up by online videos and demos, and there are links in the slides. I haven't actually uploaded the slides yet, but I'll do that first thing after this presentation finishes. In the slides, there are links to videos and demos, which will take you through each of these use cases. I'm going to attempt to go through them now with my presenter notes, but there are also some videos that do a really good job of going through those and explaining kind of what you can achieve, what all the moving parts are to make that work. And then we will try and go through, as I said, that one demo video to show kind of one of these solutions in action. So the use cases we're going to go through, the first one is no-code open APIs in minutes. We're going to show how we can use a combination of tools like WASI Analyze, ZOS Connect, and WASI Sandbox to develop APIs, exposing existing information from your ZOS applications without developers having to write any code, and show how all of that has kind of integrated testing support. How we can use the cloud native developer tools that come from the WASI portfolio to edit, debug, and build ZOS applications with cloud native tools. So that's looking at WASI Code and WASI Sandbox. How we can use WASI Analyze to do rapid application analysis. How you can extend and enhance your ZOS applications with open enterprise languages. So looking at developing extensions to your applications in Python, Go, and Node, techniques you can use to have those interact with your core business applications and the value you can get out of that. Automated software management through Cloud Broker and Z Package Manager, and on-demand ZOS environments and resources from WASI Sandbox, and one of our newer offerings in this space, which is WASI as a service, which isn't strictly part of ModStack, I don't think. So the first scenario we're going to go through is no-code open APIs in minutes. So this is looking at WASI Analyze and ZOS Connect, and I think it includes WASI Sandbox as well. So the scenario we're going through here is an API developer has been tasked with implementing a new API for their company's credit card application. The OpenAPI 3 specification that was given to the developer describes 50 new API operations which have been designed by the company's API governance board. Now, this is actually a bit different to the way this would have worked with ZOS Connect in the past, because what we're going to do is we're going API first. So we have a pre-designed shape of an API which we need to fulfill and we need to work out how to get the relevant data out of our ZOS application and into RESTful JSON API. So let's walk through the steps that a developer can execute using the IBM Z and Cloud Mod stack. So the first thing the developer is going to do is some analysis using WASI Analyze to explore the credit card application and identify programs, copybooks, and data that can be used to satisfy each of the API's operations. The developer then clones the Git repository for the application and creates their own instance of it in the code-ready workspace using WASI Sandbox. So WASI Analyze is a cloud-native analysis program, application, and what its capabilities are, it gives you a web-based experience that a developer can use to look up components of their application and find how they're referenced by other components. So for example, you can take a COBOL module and you can show a call graph to show how that COBOL module is called by other modules and which other modules it calls. And you can do things to change how many subsequent hops you see in that graph. You can look up which copybooks that program's using, and that all works using source code analysis. And it's all cloud-based, so you can provision all this stuff natively on OpenShift. You clone your repository and you open WASI Analyze against that repository, and then in your cloud-based WASI Analyze window, you can perform that analysis. You can look for the data that you're interested in, find that. You can find if you have to make changes to that to best accommodate it in some API development, what other things are going to be affected by that, perform some really detailed analysis without having to root around the code directly.
Hi, Stu, there is a question. Is this similar to ADDI?
This is similar to ADDI, but this is strictly source code analysis at this point, where ADDI pulls information from other places too. So it does things like runtime analysis and SNF records and bits like that, I think.
Thanks.
So the next step is the developer creates a ZOS Connect designer instance in their workspace. That's another cloud native thing. So you have your OpenShift platform, you've created an instance of WASI Analyze, now going to create an instance of ZOS Connect designer. So if you've used ZOS Connect before for OpenAPI 2 API enablement of your ZOS programs, you'll know that the experience for developing your APIs is there's an Eclipse plugin, and you have to have software installed on your laptop or your desktop environment. You install Eclipse. So from Aquastack, you install the ZOS Connect plugin, and you use the ZOS Connect plugin to map from your COBOL copybooks into an API. I think there are a few options about which direction you go. For OpenAPI 3 for ZOS Connect, there's no more Eclipse tooling, so everything is cloud-based now. So there's a OCI container image that's published. We published the IBM container registry, and that has the API designer application in. You can use the ZOS Connect operator to stand up an instance of API designer in a developer's project on OpenShift to provide access to the API designer application. Then it's a full web-based experience for doing that mapping. And as I said before, we're going from the API first. So the API has already been designed, and we're going to translate that into fields from the copybook. And there are some really nice new sophisticated features for making changes to the data at the copybook in the API mapping layer as well. So there's a built-in query language called JSON you can use. So if you had, for example, two separate fields in your copybook, one for first name, one for surname, but in your JSON document that you wanted to produce for your API, you just wanted one field that was name, that was the conjunction of first name with surname, then you don't have to change your native application to achieve that. You can do that all in the mapping layer using the inbuilt query language, and you can configure all of that in the UI editor. And then you build a code specification that describes how that works, which can be committed to your source code repository so that it can be built as part of your DevOps pipeline. So it means you can go much more sophisticated mapping capabilities, cloud native developer experience, and you can capture all of that as human readable source code. So you can track changes to that as your application and your API requirements evolve. Whoops, one too many. And then the third step, the developer tests the API mappings from ZOS Connect Designer as they go. So this is one of the really nice features of ZOS Connect Designer, is it actually has an embedded instance of the ZOS Connect runtime running within it. Because previously ZOS Connect was a product that you installed on ZOS, with the latest versions of ZOS Connect and for OpenAPI 3 support, you have the option of either continuing with what you're doing currently and installing ZOS Connect for your production use cases on ZOS, or you can run it as a containerized application on OpenShift. And because of that, it means we can just run the ZOS application on OpenShift as part of Designer in our development workspace. And you can configure that so it's connected to whichever system is backing your data. So that could be CICS or DB2, COBOL or PL1, in terms of like what data you're translating. But you can connect that those backing Z services to your development environment as well. So what that means is you can try out your APIs with real data from your development systems or from your test systems directly in a developer's workspace. So there's an integrated API tester part of the ZOS Connect Designer. So after you've gone through your mapping process, you can enable the testing mode, flip over to a different part of the UI, which shows you what your API looks like, and you can provide some sample input data, click the test button, and it will run the whole process for real in ZOS Connect like it would in a production environment. Obviously, you can have different configuration in your development environment for fewer constraints or things like that to make development smoother. So it doesn't have to be exactly the same, but you can make it like really close to how you run it in production. And you can try the APIs out in situ and see what response you get back. So you can be really confident that you've created the right thing and you're populating it with the right data. One of the other things about this scenario, which is not really covered in these steps, is talking about how the application that's backing it, say you're backing this API with a CICS application, there are capabilities in ModStack that mean you don't have to run that CICS application on real ZOS hardware anymore. And there are some interesting reasons that you might want to do that. We've, for a long time, had a portfolio of different offerings around virtualized Z environments, and the motivations for using those are going to be similar for all of those, regardless of what they are. It's going to be about giving developers more autonomy and insulating everyone from each other's changes. So being able to give developers a private environment where they can make changes without worrying that those changes are going to affect everyone else if you're running on some shared infrastructure. And it'll also give you the opportunity to give, as system programmers, to give developers more latitude in understanding what they do, because you're not so worried about it being an irreversible configuration change that you won't be able to recover from. And there are some technologies we have to help you deal with that in WASI Image Builder, etc., to kind of capture the state of a system so you can restore back to that in the future. So in this scenario, one of the things that you might be doing at this point is you've developed your API, you're running it on ZOS Connect rather than running it against a real ZOS system, you're running it against a completely private provisioned ZOS using a technology called WASI Sandbox. Now, WASI Sandbox is our ZOS virtualization technology that's part of ModStack. It's OpenShift native, so you get an OpenShift operator that you can empower developers to use to be able to self-service provision virtualized Z environments to deploy the infrastructure they need to in order to be able to carry out the development tasks. So you can provision, in this kind of cloud native world, developers have the ability to provision everything that they need to be able to carry out a development task. They can have access to a real ZOS Connect, they can have access to a real CICS region running an emulated ZOS environment, and they can try the whole thing out as if it was pre-integrated, as if it was running like a real system. but that can be a point in time statement about how development works. You can take all the assets that you generate, and then you can push those into your automation pipeline and have it go through the process of deploying those into test systems. And at that point, you might choose not to run an emulated environment. You might run on a real ZOS environment for test and QA. And you can make a decision about which environment you want things to run in, depending on your needs at that time. And there's a link to a video for all of these on all the slides that will take you through, kind of walk through this kind of same slide, but with an explanation of everything that's going on as well. So the next scenario I want to go through is talking about editing, debugging, and building ZOS applications for ZOS with cloud native tools. Now, hopefully, as we go through these, we'll be talking about kind of related technical concepts, which should mean that I spend less time explaining kind of how all the moving parts work, and I can be like, oh, this bit's ZOS Connect again, or this bit's WASI Sandbox again, but we'll be approaching it from a slightly different perspective. So in this use case, we're looking at a developer making changes using the same tools familiar to developers across other platforms. So in this case, the developer wants to update a ZOS application that's written in COBOL using cloud native tools available in the IBM Z and Cloud Modernization stack. So we're going to be talking about WASI Code and WASI Sandbox and WASI Analyze here. So when a developer is assigned a task to modify an existing hybrid application, they can create a developer workspace. So we're talking about WASI Sandbox there. I think the term workspace is a little bit misleading here. I kind of think about it more as an environment than a workspace, but they can create a OpenShift project and provision the infrastructure that they need to be able to deploy their in-development version of their application to try it out. And that's a development pattern that will be really familiar to anyone who's used to cloud native developer approaches, where rather than using existing infrastructure that's already there and having to share that with other people, you can treat your infrastructure like a cloud, and you can borrow a piece of that compute to run the infrastructure that you need for your development task, and then return it to the pool when you're done. So once the developer's done that, they can also use the same technique to deploy, to provision editing environments as well. So they can deploy a container that runs. This has gone through some name changes recently, so you might have seen it as WASI for Code Ready Workspaces, which is based on it's still based on the same technology, but the names for a lot of the pieces change. So you might have seen it as WASI for Code Ready Workspaces, which is based on a Red Hat technology called Code Ready Workspaces. Now we refer to that as WASI Code. And what WASI Code gives you is a web-based development environment for editing code with and that environment is based on Eclipse Thayer, which itself is based on VS Code. So what it essentially looks like is running VS Code in a web browser, and into that VS Code, we've pre-installed and pre-configured a collection of extensions which provide syntax highlighting and editing support for the enterprise languages you're familiar with. So you'll get COBOL syntax highlighting and editing support with things like jumping to variable declarations and showing context messages on hover, etc., etc. And because that is a containerized application, we can deploy it with the use of an operator onto OpenShift for developers to be able to use. So rather than having to go through what they might have done in the past, which is edit things through 3270 terminal emulator or install some software on their laptop to be able to edit that code, you can provide a completely bespoke experience where you get an out-of-the-box pre-provisioned, pre-configured development environment that's set up for that developer's particular task. You can do as much customization as you want there to make it as appropriate for what you need to do. So within that development environment, it's VS Code. It has all the features of VS Code. You can do things like clone Git repository, so you can use that to pull the source code down into that cloud development environment. So you're still not pulling it down onto your laptop. It's still all cloud-based. And then before making any changes, the developer can use the integrated WASI Analyze support, so they can stand up a WASI Analyze instance on that cloud infrastructure, do some analysis, work out, how the results of that analysis are going to affect their code change. So look at COBOL call chains. It does support other languages than COBOL. I think it's COBOL PL1 assembler and Java, but don't take that as gospel because I'm not entirely sure. But they can use WASI Analyze to find out how their program is related to the other things that are going at the other parts of their application, to find out the impact of their change and be confident that they're going to make the right change. So hopefully brings the skill threshold down to be able to do that task a bit, to make it more accessible to more people. And then you get a still no software installed web-based experience for kind of like looking at the results of that analysis and coming to some conclusions about it. And now, once the developers identified where the changes must be made, they can pull up the WASI code IDE, open their COBOL source file, and make the required changes. And then once that code change is complete, they can push it to their DevOps pipeline and have that. So you get a few options here. Either you can have an automated DevOps pipeline which deploys that into your provisioned environment, or you can treat that provisioned environment like you might treat a borrowed environment from an existing pool that you already have. Your developer can go through the process of deploying that application change the way that they always would have done. It's emulate, if we're running in WASI Sandbox here, we have a virtualized ZOS environment. It's still virtualized ZOS, so you can still make a change, and then you can still have that change compiled into a load library and try it out without ever having to deliver that to source code management. So you can deploy it in whichever way you like. Maybe you're mounting files over FTP or something like that. So then our developer persona can use that sandbox to build, debug, and test the code. If you've seen any of our DevOps presentations before, we kind of have this big chart that we use to represent the DevOps cycle. And there's kind of two cycles on that. There's an inner loop and an outer loop. And the inner loop represents that kind of tight loop of development where you're making a change, trying it out, didn't do quite what I wanted, made a change. Okay, that seems to work. I'll try writing an automated test for that. Oh, there's a problem with the automated test. But you go around this tight loop of developing changes. And then once you're confident that you want those changes integrated into your application, at that point, you can push them to your Git repository to share them with the rest of your organization. And then that kind of goes into an outer loop where that goes into a DevOps pipeline and gets built for real, and go through your QA systems and eventually make it all the way through to production. And at that point, it'll come back around and you can start your next application change. Okay, we've got about 15 minutes left now. We've talked about the application analysis quite a bit, so I'm going to kind of skip ahead of this one and see if we can find another one that's a bit different from what we talked about before. Okay, so this scenario here is about enhancing existing applications on ZOS with open enterprise languages. And there's a few things that we've not talked about in this scenario yet that are part of ModStack that we can talk about in this scenario. So what we're talking about doing here is you might have your existing applications running on ZOS tightly coupled with your existing infrastructure, your existing middleware. So that might be written in COBOL or PL1. I mean, Java's been around for a long time now. I know that in CICS, we have a team that is called them internally, they're called the Modern Languages team, and they focus on a lot of our CICS integration with Java and Node.js, amongst other things. There's always like makes me smile because Java isn't the new kid on the block it once was, but you might have parts of your infrastructure that are running Java that's been around for a long time, but you might want to extend that with some new Java that you want to apply some different principles to, maybe on a newer version of Java, but it's not all created equal. As part of ModStack, we have offerings that introduce we have offerings that introduce these other languages to the environment. So the languages we're talking about here are Python, Node.js, Go, and Java. So one of the patterns we see as being really interesting is being able to extend your existing applications with these open languages. Now in CICS, we have great support for running Java as part of integrated right into your CICS transaction. Whoops. So having Java integrated right into with your CICS transaction, but you might want to take a slightly different approach and not do things that way. You have a few options around how you might do these things. So you might choose to expose a REST API with something like ZOS Connect. So you could API enable your application in your existing ZOS assets, and then alongside it, still on ZOS, you could run a Python, Node.js, Go, or Java application which integrated with your core business application over a REST API instead of being tightly coupled with it, like directly in, say, the CICS runtime. But obviously, what you'll choose to do there will vary depending on which, what's important to you based on the needs of the application, how you want to go about achieving that. You don't have to do REST APIs. Actually, there's a really interesting case study. One of the references, I think it's from, just skip ahead to the references and see if I can find the right one. And there's a link in here. It's the Open Phoenix software reference. There's a link to an article on the communities page for IBM Z and Linux 1, which is talking about extending an existing Rex application with Node.js front end to API enable it. And what they did there is they used the ability for Node.js to spawn a new application. And then they just running Node.js and Unix system services. They ran the TSO-CMD Unix system services command to invoke Rex. And then their Rex could run as a TSO application with all of the TSO integration. They could get the data back from that and represent that data with an API that's powered by Node.js running on ZOS. That's kind of an interesting article to read about the kind of different techniques you can apply to using these languages. I'm going to whiz backwards to where we were, because there's a few other things that are interesting to talk about here. The way that you can get these language runtimes installed onto ZOS, there are some new ways of doing that with ModStack, powered by some offerings called ZOS Package Manager and IBM Cloud Broker. So IBM Cloud Broker is a way of managing resource provisioning on ZOS and integrating that with OpenShift. So being able to extend the OpenShift API with assets that relate to ZOS resource provisioning. And one of the things you can do with Cloud Broker out of the box is it comes with a extension to Cloud Broker, which will allow you to install ZOS Package Manager. ZOS Package Manager is a new way of thinking about installing ZOS applications. And what it does is it pulls those applications down from an online registry and installs them for you on ZOS without having to go via SMP or anything like that. And at the moment, we have ZOS Package Manager packages hosted on IBM Container Registry for the open language runtimes that we're talking about here, and for Z Open Automation utilities as well. So Unix system services, language environments, and utilities, you can use Cloud Broker and Package Manager to install those to make managing those environments easier as well. So the language runtimes themselves are part of ModStack, and also new means of installing them as well. So this wheel here is talking a bit about that kind of relationship of Cloud Broker and Package Manager. So what you can, and there's, again, I've talked about operators. I don't think I've really done a very good job of explaining what an operator is, but it's essentially a way of providing kind of custom behavior for the OpenShift platform to make it easier to add custom extensions and custom management of resources to OpenShift. So a lot of the things you'll see that are that we extend OpenShift with will come with their own operator for helping you manage that. So there's like a Cloud Broker is an OpenShift operator, ZOS Connect has an OpenShift operator, there's a WASI code OpenShift operator, and there's a WASI sandbox operator, and you'll typically interact with those operators to provision instances of the software that they manage. It's like a the operator pattern is very much a software acting as a human operator would, so just being able to automate that for your cloud platform. There's a whole bunch of information you can read if you're interested more about the operator pattern for OpenShift and Kubernetes. So the first thing we do is we download our available software, so that's our language runtime, and we make that available to OCP as OpenShift container platform, but we make it available to OpenShift. And essentially what we do is we use Cloud Broker to register that piece of software, couple it with a ZOS instance that we want to install that software onto, and then we use Cloud Broker to drive Package Manager, and Package Manager is actually going to be the thing that's responsible for installing that software onto ZOS. But that's not the only thing that you can do with Cloud Broker. So Cloud Broker also comes with an SDK where you can extend Cloud Broker so that you can develop custom assets that you want to provision on ZOS as well. So if you have existing manual processes for delivering, for provisioning application, for provisioning infrastructure and resources on ZOS, then it's possible to write an extension to Cloud Broker, which allows you to surface those on the OpenShift API. So you can use kind of cloud native. You can develop. You effectively end up with your own operator to manage the provisioning and deprovisioning of those custom resources as well. So you can make your ZOS provisioning and deprovisioning behaviors consistent with everything else that we're doing via ModStack for the OpenShift platform as well. And then you can use Cloud Broker and Package Manager to keep those installed language runtimes or existing provisioned applications up to date as well. So there'll be an online catalog of particular versions of those. You can configure Cloud Broker to install specific versions of those language runtimes, etc., into the right places. And hopefully that reduces the skill barrier, reduces the cost of entry of maintaining software on ZOS by being able to do it through patterns that people might already be used to. So I think what I'd like to do now is try and take you through a video of the first scenario I talked about of API enabling an application, doing some analysis with WASI Analyze, kind of what that whole flow looks like. So I'm going to stop my screen sharing and I'm going to try and share a video. Hopefully that works. If it doesn't work, I'm going to try and talk you through it as it goes. And we'll be talking about that kind of first scenario we went through. Okay, can you see that video?
Yeah, we can.
Perfect. Right, what I'm going to do is I'm going to turn the sound off. It does have Will talking through it, but I might pause it and like dwell on certain bits. So I'm going to turn the sound off and I'm going to try and talk you through it. And if I do a bad job, we can always rely on Will to set us right. So yeah, in the interest of full kind of accountability, this is a video that Will had developed showing how to go through some of these processes and give you a flavor of what the tooling experience is like. So the scenario we're looking at here is making a chatbot. I just hop back to that and I can kind of explain the scenario. What we're looking at here is a chatbot to provide account details on request. I think this uses the GenApp sample application that you might have encountered through some of our other videos. What we're going to do here is take some account information from a ZOS application and kind of make it available via a chatbot. So you can go into a chatbot and say, like, what's my account balance or something like that. And in order to do that, we're going to need to API enable, get access to that data through an API. So here's the kind of web page with the chat window on the right-hand side. We want to be able to get policy details, and it's going to show us, so this is a car insurance, it looks like. We want to get policy details for an insurance policy and have that pulled from our system of record. We want to use tools that are provided in ModStack to help us achieve that. So this is also showing, I think what this is demonstrating here is that account details still display the policy details, and we need to change the application so that it shows the account details when the chatbot request asks for account details. And in order to do that, we're going to use the Cloud Native tooling that comes with OpenShift. So this screen here is showing OpenShift's Operator Hub. This is how you install those extensions into OpenShift to provide custom resource behavior. And what we're going to do is we're going to add the WASI Developer Sandbox. That's the virtualized ZOS service. That's going to allow us to deploy our backend application into that emulated environment, and we can use that at development time. So I think that screen there was showing the kind of what it looks like at the end when you have all of the infrastructure you need provisioned to carry out your development task, which can look like a lot of things. So what we're going to do now is we're going to use code-ready workspaces. We're going to start our sandbox environment in the background, and then we're going to open our cloud-based IDE so that we can make some application changes. And we're going to use a combination of WASI code and WASI Analyze to do that. So this is the result of that provisioning of WASI code. So we have this is running, it looks like regular VS Code, but it's running here in a web browser with the source code checked out, all provisioned, running on OpenShift via technology powered by ModStack. So what we're going to do here is we're going to open our COBOL source code, and you can see that the editor has COBOL syntax highlighting, and we can have navigation support to be able to jump to the right bits. What we're showing here is that we've found if we look at the information we've got there, it's like, oh, we've got the customer number, first name, last name. This looks like the account information that we want to surface through the chatbot. So we found the right piece of information. What we want to do next is work out what how that information is used existing in the application, do a bit of impact analysis, make sure it's the right piece of data, and make sure that we know if we change that, what it's going to affect. So now we're going to switch to a different part of the experience. This is WASI Analyze. And then here we have a search box at the top where we can look for a particular module within our application. This is the module that we know we're going to need to change. We can open that in WASI Analyze, and it can show us a COBOL call graph showing us that our module LGIC USO1 is called by LG test C1, and it itself calls to programs. You can see the outgoing references, and you can see that LGCM area, the COM area copybook for the customer data that we want to expose. You can also increase the number of steps that you can see in the call graph as well. I think that was showing one step, but you can up that to see more complicated interactions as well. So now we're going to go over to the ZOS Connect designer experience. So if you've used ZOS Connect in the past, this is the new web-based way of doing that. So it's the same kind of approach that you might have seen of mapping your copybook to the API, except in this case, both the copybook and the API are fixed. And we're going to kind of meet in the middle of map the data we have from the copybook to the API request. So we want to get the data for an individual customer, and we want to map that to data that's coming from the backend application in CICS in this case. So you go through this mapping experience, you pick your response codes here. So we're going to say if you get when you get a response code 200, the response is going to contain the customer data. You get this great interactive experience where you can bring up Content Assist and pick fields directly out of the copybook structure that you're coupling this with. So you go through this process of filling in all of those, and maybe it's like a one-to-one mapping where each field maps to a specific thing. but you can do more sophisticated things like I talked about before with JSON R, the query language to like concatenate fields and transform them, parse them, things like that. And then we're going to see the API tester here. So you click the test button, and this is running a real ZOS Connect as part of the designer image, and it's running against our CICS application that we provisioned into our emulated environment. So we can actually try this out, getting the customer data for customer number 10, and we can see that we get all the right information populated in our JSON response there. So we can see we've successfully API enabled this part of the application. As a result of that, we'll get all the source code artifacts for that in our WASI code environment here. We can see all the things that we've changed as a result of generating that mapping. We'll get source code artifacts, and we can go to the integrated Git view in WASI code and commit those changes to source code repositories so they can go through the pipeline and be built and tested, pushed to QA systems, and eventually make it to production. And then at the end, we can see that now we can ask our chat assistant for account profile, and we get account information back instead of insurance policy details. So we've successfully made those updates there. So hopefully that was a nice kind of way to finish up, to show some of those things you can do with ModStack in action. The slides have got lots of links in for all of these different scenarios, and much more reading you can do on the offerings that are part of ModStack. And as always, if this is something you're interested in having more discussion about, please reach out to me either directly or through Rob or Jenny, and we can carry on some dialogue there. But thank you very much for listening.
Thank you very much, Stu. Okay, folks, if there's no more questions, parting in such sweet sorrow, I'll I better post a link up for the next one. Just bear with me a moment. Yeah, this is the last session. Please give feedback. So far, the numbers have been a great success for the conference, but obviously we just want to widen our community as much as we can. Thank you, Jenny, for posting the link and beating me to it. And hopefully I'll see you all face to face, either in the UK or elsewhere. Thanks very much, Stu, and cheers, everyone.
Thank you, everyone.
Bye-bye.
Bye.